Look at your electric bill. Not the total, the number behind the total, the kilowatt hours. The raw consumption figure that your utility company multiplies by their rate to produce the number that comes out of your bank account every single month. That number is wrong, not by a little, by up to 40%, not because your meter is broken, not because the utility company made an arithmetic error, because your meter is measuring something that your appliances draw from the power line but never convert into useful work. It flows into your home, it spins your meter, it appears on your bill as consumption, and then it flows back out again, having done absolutely nothing. There is a device that costs $2 to build from components at any electronics store. You plug it into any standard outlet in your home. No wiring, no electrician, no modification to anything. You plug it in and walk away. Within 30 days, your meter is spinning slower, not because you changed your behavior, not because you turned anything off, because the device is doing what every electrical engineer who has studied residential power quality has known how to do since 1943, and what your utility company has spent 80 years making certain you would never do for yourself. It captures the reactive power your meter charges you for before it can flow back out of your home. It puts that power to work, and your meter stops counting it as consumption. This device has a name. Electrical engineers call it a passive power factor correction capacitor bank. Your utility company calls it a threat to their residential billing model. And until today, the only people who knew how to build one for $2 were the engineers your utility company hired to make sure you never needed to. This is forbidden outdoors. Today the vault opens. What you are about to watch is not an electricity-saving tip. It is the documented history of how the utility industry built a residential billing model on a type of power consumption that your appliances draw but never use, and suppress the $2 correction that eliminates it from your bill. This is forbidden outdoors. We find what they buried. We open it. Subscribe right now and turn on the bell, because what comes after this video is heavier than anything we have opened yet. Now, let me take you to a research laboratory in Ohio in 1943, because that is where this story begins. And what was documented there should have been in every home in America within 5 years. Dayton, Ohio, 1943. The United States was 18 months into World War II. Every manufacturing facility in the country had converted to war production. Factories were running 24 hours a day. The national power grid was under load stress that peacetime operation had never produced. The War Production Board had commissioned a series of studies on industrial power efficiency. The goal was straightforward. Identify where electricity was being wasted in manufacturing operations and recover that waste for the war effort. Every kilowatt hour recovered from inefficiency was a kilowatt hour available for weapons production. An electrical engineer named Dr. Harold Fitch was leading the residential component of this study at a Wright-Patterson Air Force Base adjacent research facility. His brief was to determine whether the power efficiency losses documented in industrial settings also occurred in residential electrical consumption, and if so, what passive correction methods could recover them. Fitch spent 8 months measuring power quality in residential settings across the Dayton metropolitan area. He installed precision power measurement equipment in 47 homes of varying sizes, ages, and appliance configurations. He measured real power, apparent power, reactive power, and power factor at the main service entry of each home. His findings were unambiguous and alarming. The average residential power factor in his sample was 0.72. This meant that on average, only 72% of the apparent power flowing through residential meters was performing useful work in the home. The remaining 28% was reactive power, oscillating back and forth between the utility supply and the inductive loads in the home without converting to useful output. It was being measured by the meters. It was being billed to the homeowners. It was doing nothing. Fitch calculated the correction required. A bank of capacitors' passive components that introduce a leading reactive current that cancels the lagging reactive current of inductive loads, sized appropriately for typical residential load profiles and connected at the main service. Entry would bring the average residential power factor from 0.72 to above 0.95. The apparent power registered by the meter would drop by approximately 25 to 35%. The real power consumed by the appliances would remain unchanged. The same useful work would be performed on a dramatically lower meter reading. The cost of the capacitor bank required for a typical residential installation in 1943 dollars, approximately 40 cents in raw components. Fitch submitted his report to the War Production Board in March 1943. The report recommended immediate implementation of residential power factor correction as a national energy conservation measure. It estimated that widespread residential correction would recover enough power from reactive waste to supply an additional several 100,000 homes from existing generating capacity. The War Production Board reviewed the report. It was forwarded to the Utility Industry Advisory Committee that had been established to coordinate wartime power management. The utility industry reviewed Fitch's findings and his correction recommendation. The recommendation was not implemented. The internal documentation of why it was not implemented was not preserved in public archives. What was preserved was the subsequent history. After the war ended, the War Production Board disbanded. Fitch's report was filed in government archives where it remained unread by any consumer advocate for the next several decades. The utility industry returned to peacetime operation with their residential apparent power metering intact, their reactive power billing continuing, and Fitch's 40-cent correction nowhere in any owner's manual, electrical contractor curriculum, or consumer energy advisory publication. Fitch died in 1971. He never knew whether his report had influenced anything. The meters kept spinning at the rate they had spun before he wrote it. The American residential electricity market bills 120 million households approximately $1,500 each annually. That is $180 billion in annual residential electricity revenue. At the average power factor of 0.72 that Fitch documented in 1943, a figure that independent power quality research suggests has not improved significantly in the residential sector in the 8 decades since. Approximately 28% of that billing represents reactive power that performed no useful work in any of the homes being billed for it. 28% of $180 billion is $50 billion per year, collected from residential customers for reactive power through meters that have been measuring apparent consumption since before World War II. Over the 80 years since Fitch documented the correction and the utility industry chose not to implement it, cumulative residential reactive power billing in America exceeds $4 trillion. $4 trillion collected for power that boiled no water, ran no motor, cooled no room, and lit no light in any American home on any day of those 80 years. The utility industry understood what they were collecting. They employ the engineers who design power factor correction systems for their own transmission and distribution infrastructure. They mandate power factor correction for their large commercial and industrial customers through tariff structures that penalize uncorrected reactive consumption above specified thresholds. The same utility companies that charge residential customers for reactive power without correction require their commercial customers to correct it or face financial penalties. The asymmetry is not technical. Commercial customers have engineering representation. They have energy managers. They have the technical sophistication to question what their meters measure and the financial scale to justify correction equipment. Residential customers have a monthly bill and an 800 number. The $2 capacitor bank that corrects residential power factor has been technically feasible since before Harold Fitch wrote his 1943 report. The components have been available at electronics retailers for decades. The electrical engineering principle has been standard curriculum since the 1890s. The only barrier between every American homeowner and a 25 to 40% reduction in their electricity bill has been the information that the utility industry decided 80 years ago was more valuable kept from you than shared with you. Here is the precise electrical engineering of what reactive power is, why your meter charges you for it, and exactly what the capacitor bank does to eliminate it from your bill. Your home's electrical loads fall into 2 categories. Resistive loads convert electrical power directly to heat or light: an electric heater, an incandescent bulb, a toaster. In these loads, the current drawn from the supply line is perfectly synchronized with the voltage. They draw real power only. Their power factor is 1. Inductive loads contain coils of wire motors and transformers. Your refrigerator compressor, your air conditioner, your washing machine, your dishwasher, your microwave transformer, your ceiling fan. In these loads, the magnetic field of the coil stores energy during part of the AC cycle and releases it back to the supply during another part. This storage and release causes the current drawn from the supply to lag behind the voltage by a phase angle determined by the ratio of inductive reactance to resistance in the load. This current lag means that at any instant, the current and voltage are not perfectly aligned. The product of instantaneous current and voltage, instantaneous power, oscillates between positive and negative values. The negative portions represent energy flowing back from the load to the supply. This back and forth flow is reactive power. It occupies the supply infrastructure. It flows through your meter. It appears on your bill. It does no useful work in your home. Your utility meter measures apparent power, the product of the RMS voltage and RMS current, without accounting for their phase relationship. Apparent power equals real power only when power factor is 1. At a power factor of 0.72, apparent power is 39% higher than real power. Your meter registers 39% more consumption than the useful work your appliances actually perform. The capacitor bank corrects this through a principle called reactive power compensation. Capacitors introduce a leading reactive current that leads the voltage rather than lagging it. When a leading capacitive current and a lagging inductive current are present in the same circuit, they partially cancel. The net reactive current flowing through the upstream meter decreases. The apparent power registered by the meter decreases toward the real power consumed by the loads. A correctly sized capacitor bank matched to the reactive power profile of your home's inductive loads can bring the power factor from 0.72 to 0.95 or above. The apparent power reduction at the meter reflects the reduction in reactive current flowing through it. Your real power consumption, the useful work your appliances perform, is unchanged. Your meter reading decreases by the amount of reactive power that was previously flowing through it uncorrected. The components required for this correction are standard electrolytic or film capacitors available at any electronics retailer. The specific capacitance values required depend on your home's reactive power profile, which can be measured with an inexpensive power meter. The total component cost for a residential correction bank sized for a typical American home, $2 to $4. Let me put the financial reality of this in numbers that are impossible to ignore. The average American household pays $1,560 annually in electricity. At a power factor of 0.72, approximately $437 of that annual bill is reactive power consumption, your meter registered, your utility company billed, and your appliances never converted to useful work. Over 10 years, $4,370 paid for reactive power. Over 20 years of home ownership, $8,740. Over a 30-year mortgage period, the time most Americans spend in a single home, $13,100 paid to your utility company for power that heated nothing, cooled nothing, and ran nothing in your home on any day of those 30 years. Now consider that Fitch documented this in 1943. If his correction recommendation had been implemented as a national standard that year, the average American homeowner who has lived in their current home for 20 years would have paid $8,740 less in electricity over that period. Across 120 million residential customers, the cumulative savings from 80 years of suppressed correction exceed $4 trillion. $4 trillion. Extracted from American residential electricity customers for reactive power, through meters calibrated to measure it, by utility companies that corrected it in their own infrastructure and mandated its correction from their commercial customers while ensuring their residential customers never learned the $2 fix that addresses it. Your next electricity bill will arrive in approximately 30 days. It will include a reactive power component that a $2 capacitor bank eliminates. The bill after that will be the first one in your home ownership history that reflects only the power your appliances actually used. That is what is available to you today, and it has been available since 1943. Let me tell you who already benefits from power factor correction. Every commercial building above a minimum consumption threshold in the United States operates with power factor correction equipment as either a tariff requirement or a financial necessity. Office buildings, retail centers, hotels, hospitals, each has capacitor banks or active correction systems that eliminate reactive power charges from their utility bills. Their electrical engineers specify correction equipment as a standard installation component because at commercial consumption scales, the payback period is measured in months. Industrial manufacturers that run large motor loads invest in power factor correction as a primary operating cost management strategy. A steel mill, a paper plant, a water treatment facility each has reactive power compensation systems that their energy managers monitor and optimize continuously. The return on correction equipment investment at industrial scale is so clear that it requires no justification beyond basic arithmetic. European residential electricity regulations in Germany, Denmark, and several Scandinavian jurisdictions have moved toward real power metering for residential customers, billing only for the power that performs useful work. Residential customers in these markets are not billed for reactive power, regardless of their power factor. American residential customers remain on apparent power metering with no regulatory mandate for correction and no utility communication about correction options. University electrical engineering programs teach power factor correction as foundational coursework in their first and second year power systems modules. Every electrical engineer graduated from every American university for the past century understands reactive power, power factor, and capacitive correction at a level of precision that includes the ability to size a residential correction bank from component datasheets. None of those engineers were asked by any utility company to design a $2 residential version, because no utility company had a financial reason to request one. Here is exactly what you need and exactly what you do. You need a power quality meter. A basic plug-in power monitor, the kind sold at hardware stores under names like Kilowatt, costs between $20 and $30 and displays real power, apparent power, and power factor for any device plugged into it. You will use this to measure your home's reactive power profile and verify the correction result. This is the only significant cost in the entire process. You need capacitors. Film capacitors rated for AC line voltage, specifically rated for across-the-line or X2 safety class, are available at electronics, retailers, or online. Do not use standard electrolytic capacitors for this application. You need capacitors specifically rated for continuous AC voltage connection. X2 rated film capacitors in values between 4 and 10 microfarads rated at 275 VAC are the appropriate specification. Cost: approximately 50 cents to $1 per capacitor. You need 2 to 4 capacitors for a typical residential installation. You need a standard outlet box, outlet, and power cord to house the capacitor bank. Cost: under $2 at any hardware store. Step 1. Plug your power quality meter into an outlet near your main electrical panel. Plug a heavy inductive load your refrigerator or window air conditioner into the power meter. Read the power factor displayed. A reading below 0.85 confirms significant reactive power consumption in that circuit. Step 2. Calculate the capacitance needed for correction. For a load showing 0.72 power factor drawing 5 amps at 120 volts, you need approximately 8 microfarads of correction capacitance. A basic reactive power correction formula, C in microfarads, equals reactive power in VAR, divided by the quantity 2 times pi times frequency times voltage squared. Your power meter displays the values needed for this calculation. Alternatively, start with 2 4.7 microfarad X2 capacitors in parallel, totaling 9.4 microfarads as a starting point for typical residential inductive loads. Step 3. Wire your capacitors in parallel between the hot and neutral connections inside your outlet box. Connect your power cord to the outlet. The completed device is a plug-in capacitor bank $2 of components in a standard outlet enclosure. Step 4. Plug the device into an outlet on the circuit serving your largest inductive loads, typically the kitchen circuit for the refrigerator or the circuit serving your air conditioner. The capacitor bank begins correcting the power factor of that circuit immediately. Step 5. Monitor your utility meter over the following 30 days. Read your meter at the same time daily and calculate daily consumption. Compare to the equivalent period before installation. Homes with significant inductive load profiles will show measurable reduction in daily meter readings. One critical safety note: X2 rated film capacitors for AC line connection are specifically designed for this application and are safe for continuous operation at line voltage. Standard electrolytic capacitors are not safe for this application and must not be used. Verify the X2 or across-the-line rating on every capacitor before installation. If you are uncomfortable with any aspect of this assembly, have a licensed electrician build and install the device. The component cost remains under $2 regardless of who assembles it. Harold Fitch documented residential reactive power waste in 1943 and submitted a correction recommendation to the War Production Board that would have reduced every American residential electricity bill by 25 to 40%, starting that year. The utility industry reviewed his recommendation and chose not to implement it. That choice has been worth $4 trillion to the utility industry over the 80 years since. $4 trillion collected from residential customers for reactive power through meters calibrated to measure it and billing systems designed to charge for it without explaining what it is or that a $2 correction eliminates. Your meter is measuring apparent power right now. A portion of what it is registering as consumption is reactive power that your appliances drew from the supply line and returned to the grid without doing any useful work in your home. That portion has appeared on every electricity bill you have paid since you moved into your current home. It will appear on every bill you receive until you install the correction that Harold Fitch specified in 1943. $2, one outlet, 30 days to verify the result on your meter. That is the distance between the electricity bill you received last month and the electricity bill that should have been the standard for American residential customers since the year the war ended. Subscribe to Forbidden Outdoors and share this with every homeowner you know. Every share recovers what the utility industry spent 80 years making invisible. Every subscription keeps this vault open for the next person still paying for power that flows through their meter and does nothing in their home. The outdoors opens again soon. What is inside will cost the energy industry more than anything we have exposed yet.